Okay, so we're talking about the differences when you use combination, sorry about the spelling, or permutation. Okay, so we want a committee. Is that how, Miss S, is that how I spell committee? I-T-T-E-E. Okay, a committee of 4 students out of 32. Okay, so what do we think? Is this a combination or a permutation? So, does it matter if I list the people that are in the committee? If it goes Abby, Kayla, Manny, Jason, or Jason, Manny, Kayla, Abby? Does the order matter? So this would be a combination. So this would be if order doesn't matter, it's a combination. So this would be 32, combination 4. Or you could write it as combination 32, 4. So I'm going to hit my menu again. 5 combinations 32, 4. And I get 35,960. Remember, you can also, if you don't have a combination button on yours, if you have a factorial button, you can do it. Remember, it's n factorial over r factorial times n minus r factorial. So you can write this also as 32 factorial.
What is n and r?
N is the number of possibilities, and r is the number of options.
So 32.
Yep, 32 factorial, 4 factorial, minus 32 minus 4 factorial. Okay?
So how am I supposed to know? Because I would look at that and then I think about the warm up and I just do 4
Okay.
How am I supposed to know that?
Well, this is not, it doesn't have anything that repeats would help for a first one that you would say.
Okay.
Because I don't have 2 Abbies in this class, right? I can't have you be the 4 members of the committee. So it's like logic. You have to actually read the problem and think about it. Okay, so this is how it would change. So again, I want a committee of 4 students out of 32. 1 will be the president. 1 vice, 1 treasurer, I don't know how to spell that, 1 secretary. I don't know how to spell that either. Okay, so how is this different?
Bro, stop airdropping shit, dog. Bro, fuck.
I'm sorry, you need to leave my classroom now. Go. Thank you. Okay, so how are these 2 different? How is this different than this?
It's more like the 4 students have roles now rather than just.
The 4 students have roles. So now, is it a different committee if you're the president, Abby, or if Jason's the president? Yeah, it's different, right? Like, it matters. The president makes the decisions, the vice president backs them up, the treasurer gets to handle all the money, and the secretary has to write everything down. I don't know about you, but when we were in groups like this, I was like, don't make me the secretary, don't make me the secretary, right? So that matters to you. So order now matters. So instead of a combination, it is a permutation. So this would be a permutation, 32, 4.
The first one be a permutation too because of the fact that you're only picking 4 students.
No, because order doesn't matter, because the order of those 4 students doesn't matter. It doesn't matter who I call out first. This one, if I call out the president first, that matters because you could change roles, change who the president is. Okay, let's move to permutations versus combinations worksheet. Okay. So, for problems 2 and 3, we're going to use the list of all the permutations of the letters R, S, T, and N using 3 at a time. First of all, defining permutation means order matters. That's how I remember it. Okay. Number 2, using the permutation listed above, put them in groups that contain the same 3 letters. I recommend doing this with a highlighter or some way to circle it in different colors. I'm going to use different colored pencils so you guys can see. Okay? So we are circling the ones, and I want you guys to actually be doing this with me. Do not have your head down. Do not be on your phone. Okay. So we are looking right here. RST. So these all have R, S, and T in them. Do we agree? Those 6 at the top? So these, that group. Okay? This group right here, I want to do N, S, and R. So this has N, S, and R. That has N, S, and R. Where else? N, S, R. N, S, R. Any others? N, S, R, these. Okay, so these ones in orange. That's another group, right? You guys with me so far? Okay. My pencils are all not very sharp. Okay, we've got RTN. 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 Okay? And then my last group is this one here. Okay. All right, so we've got all the ones that contain the same letters. That's what we did for number 2. Number 3. By definition, a combination is a collection of objects in which order of the objects doesn't matter. How many groups do you have for number 2? How many different colors did I use up there? 1, 2, 3, 4. Good. 4. So, combinations, how many combinations do I have? I have 4 because there's 4 groups. But permutations, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I have 24. So if I said, I'm going to use the letters R, S, T, N, and I'm going to take 3 out of the 4 of them, if you wanted a permutation saying order matters, you'd have 24. But if you were taking a combination saying order doesn't matter, you'd only have 4. Okay? Is that starting to make a little sense? Combinations versus permutations? All right. For problems 4 and 5, we're going to use the given below of all the permutations of S, R, S, T, and K using only 2 at a time. Using the permutations below, split them into groups that contain the same 2 letters. So here's a group. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's 20 permutations. There are 10 combinations. Okay, order matters. There's going to be more possibilities. Is that starting to make sense? Whenever you see a permutation, it's going to have a bigger answer than your combination. Okay, we're going to now,
Could you go back there?
yeah. So for permutations, I end up with 4. For permutations, I end up with 24. For combinations, I ended up with 4. Permutations, I had 20. Combinations, I had 10. Okay. So, we're going to try to experiment using factorials to write these expressions, but we're actually not, because we already know what to do. So instead of listening to the directions here, we're just going to talk about how we can put them in the permutation and combinations. Okay, so for number 6, how am I going to write this combination? So if I want to put it in my calculator, I know I have a combination. What numbers am I going to put in there? So we found out that there were 4 possible combinations, right? But if we just read this problem, given below are the permutations of letter R, S, T, and N. We can only use 3 at a time. So how many possible letters are there? I'm going to zoom back in. Let's count them again. How many letters are there? 1, 2, 3, 4. But there's only 3 slots I can fill them in, right? So how am I going to do this? I'm going to write combination what, comma what? 4, comma 3. It's always the bigger one first, then the smaller one. Okay? And that is going to give you, the answer is going to be 4. Okay?
Pardon for the interruption. Attention all staff. At this time, could you please dismiss the boys freshman and JV basketball team to meet their bus at the west end pool door? Once again, please dismiss the boys freshman and JV basketball team to meet their bus at the west end pool door. Thank you.
All right. So for 5, what would I write? The combination would be what, comma what? So I'm looking at number 5. 5 has, if you look up here, we've got 1, 2, 3, 4, 5 letters, but we can only take 2 at a time. So what's that going to be? 5, comma 2. There are 5 letters, and I can only take 2 at a time. So I'm looking at number 5, so I'm looking up above. For problems 4 and 5, use the list given below of the permutations of letters R, S, T, N, and K. Use 2 at a time. Like this. So there's just 2 slots, okay? And I can put 5 different letters in the first one, 5 different letters in the second one, okay? So it's 5, comma 2. 5 different possibilities, but I can only take 2 at a time. I think of it as like slots. Okay, so Abby, you have 2 keyholes that you have to stick your key in to open the door. And you have 5 keys. So you put 1 key in, unlock it, take them back out, put another key in, unlock it. But you can only try 5 keys, but there's only 2 locations to put them in. Okay? I'll keep coming up with new scenarios until one makes sense for you. All right. Using what we learned, we want to write an expression where you have 100 objects, and we want to know how many combinations using 29 at a time. So we're going to do a combination. What am I going to put in for that combination? And then we're going to put in our calculator to figure it out. 100, and then what? Comma 29, right? Okay. So then get out your calculator. You guys should try this because you don't want to get to the test and not be able to, or the quiz, not be able to put them in your calculator. So what do you guys push again? You're in a calculator page. What buttons do you push? Menu, and then what? Probability. And we're doing a combination. So we push 3, right? And then we push 100, comma 29. I'm going to tell you right now, if you put them in the wrong order, if you put the smaller one first, it's going to say it's not possible. Right? Yeah, it gives you 0 as an answer. We're not going to write this number down. Are you guys okay with that? What? How many digits is this number? Yeah, like 18? Yeah, okay. We should get this. I'll put it up here. Yeah, I don't want to write that all down. But you guys got that, correct? Okay. All right. Given the 3 letters, W, H, and O, list all the permutations using 2 letters at a time, and then we're going to list all the combinations. Okay, so all the permutations. If we're going to go W, H, W, O, okay, then we can go H, O, H, W. Then we can go O, W, O, H, correct? Is there any others that we can do? What's the other way we could figure this out? This first one, it says it's a permutation. So if we're doing a permutation, how many letters are there? How many possible letters can I put in? 3. How many at a time can I choose? 2. So if I hit menu, probability, permutation, I can hit 3, 2, and I get 6. That's how many I have here. Right. And I got the 2 because it said I can only select 2 at a time. Yep, because order mattered. The next one said combination. How many combinations are there? So I'm going to say combination 3, 2. And how many do you guys guess it's going to be? How many combinations are there up there? 1, 2, 3. Because there's 3 groups, right? So I hit menu. Yes. 3, and I put 3, 2, and I should have 3 is my answer, correct. Okay, why don't we stop there? You guys are going to do the back. You're going to set them up as if they're a combination or a permutation. And let me tell you this, I do not want you to do, try 13, but you might not get it right because I haven't taught you that part yet. And 14, you do not have to do C. Do A and B, yep. So you have 1, 2, 3, 4, 5, 6, 7 problems to do, and 13 is your rough estimate. And you're going to tell me, you're going to write out the thing like this for permutation or combination. That's all you got to do. Tomorrow, I'm going to give you the review for the quiz. I'm giving it that early, so we're going to just work on that in class tomorrow. And then Thursday, we're going to go over the answers, so you have the answers to study. And then Thursday, we're going to do a matching activity where I give you a bunch of scenarios and you match which one's the permutation, which one's the combination with it. And then you match the answer. And we'll work in pairs to do that, and I'll let you guys pick. Okay? So that's what we're doing. Questions, comments, concerns? Okay. Let's hit the lights.